Welcome to RB CodeCrush. Today our topic of discussion is deletions in a linked list. Now, there are three cases of deletions in a linked list. Case 1, deletion of the first node. Case 2, deletion of a node from any position. And case 3, deletion of the last node. Now let's concentrate with case 1, which is deletion of the first node. Let this be our original linked list, and this is the first node of the linked list which needs to be deleted. Hence, after deletion of this first node, the current second node becomes the first node, which should be pointed by the root after its deletion. For such modification before deletion, we take a node type of pointer ptr which points to the first node and which temporarily stores the address of the first node which needs to be deleted, that is equal to the address stored in the root. So we can easily write ptr equals to root because root and ptr is pointing to the same node, that is having the same address. And we see after deletion the root will point to the current second node, that is the same node which is presently being pointed out by the first node, or in simple words, root will have the same value as contained in the link part of the first node. Thus we write root equals to link of ptr, and ptr means the first node, ptr pointing to the first node. So root is now having the same address which is contained in the link part of the first node. Lastly, after our deletion operation is completed, we free the memory space which was previously used by the deleted node for future use. This can be done by writing free ptr, that is free the memory location pointed out by the pointer ptr, and we know that ptr points to the first node. This is our modified linked list where we find the second node of original linked list becomes the first node. Now let's go to the code part to make ourselves more clear. Here is the coding part. I am not going to explain the create function because it has already been explained in previous video. If you want, you can go back and check out the explanation. Let's start with the function del_beg. This function helps us to delete a node at the first, occurring at the first. So we have already seen that the ptr points to the first node which is also being pointed out by root, so we write ptr equals to root. Then after deletion, root will point to the second node, that is it will contain the address which is contained in the link part of the first node, which we write as ptr of link. And then after deletion, we will free the memory location which was previously being occupied by a memory location which is pointed out by ptr. Let's now discuss about case 2, deletion of a node from any position. Suppose this is our original linked list. Now we ask the user which node he desires to delete. Let that be the key node, and key variable stores the info part of the key node. From this diagram, we can see that the key node is the node which contains the value 5. Hence, 5 will be stored in key variable. Now we traverse through the linked list with the help of a pointer ptr, which temporarily points to each node until it reaches the key node. There is another pointer ptr1 which points to the immediate predecessor of the node pointed out by PTR. From the pictorial representation, we find out that after deletion of the key node, the immediate predecessor of it points out by PTR1 will be pointing to the node presently pointed out by the key node. Key node is deleted. Once again, let's see what happens. Traverse through the linked list until key node is reached. That is, until PTR points to the key node, we should go on traversing through the linked list. In the modified linked list, link part of the node before the key node contains the same value as the link part of the key node. So the node before the key node is being pointed out by PTR1. Hence the link part of that node is written as link of PTR1, which will have the same value as the link part of the node being pointed out by PTR, that is the key node. Then we free the space occupied by the deleted node pointed out by the pointer PTR. Finally, we come to see the modified linked list as given. Now let's move on to the coding part. Here is a function known as deletion or del_any, and there is a parameter called key. This takes the info part of the node which has to be deleted. In this function, we have already seen how to delete any node in a linked list. So in while loop, we will write that until and unless we reach the last node, and until and unless the info part of the node contains key, we will continue to traverse to the linked list. Why do we write this? Two situations can arise. One, that is, the node which the user wants to delete is absent from the linked list. In that case, the nodes will not have the key value. Not even one node will have the key value. So we will check till the end of the linked list in that situation. So our traversal will end when we reach the last node, that is the node having a null pointer. Another situation is the node which the user desires to delete is present in the linked list. In that case, PTR will point to the desired node, and we will stop the traversal when we see that the info part of the node pointed out by PTR, that is PTR of info, has the key value. And so we give this kind of condition within while loop, and we see that inside while loop two statements need to be executed. One is PTR1 equals to PTR, that is the pointer which points to the predecessor of the node which is being pointed out by PTR. Because you see in the next line only it is said that PTR equals to PTR of link. So PTR will point to the next node being pointed out by PTR1. After we find the node which the user desires to delete, we will jump out of the while loop and we will do the following, that is PTR1 of link will become the PTR of link. Why it will become, it has already been explained. And after deletion of the node or the key node being pointed out by PTR, we will free the space which it was occupying previously. This is given by free PTR. Moving on to case 3, deletion of the last node. It is very easy. Assuming this to be our original linked list, last node is the node containing the null pointer. We now need to traverse through the linked list until the last node is reached. PTR is a node type pointer which we have already seen helps us in traversal, and we continue to traverse until PTR points to the last node. There is another pointer called PTR1 which points to the immediate predecessor of the node pointed out by PTR. From the diagram we find that after deletion of the last node, the second last node points to null once again. We will traverse the linked list until and unless we find that the link part of the node being pointed out by PTR contains a null pointer. Okay. Then in modified linked list after deletion, link part of the node pointed out by PTR of 1 contains a null pointer, because after traversing through the linked list, when we reach the last node that is pointed out by PTR, at that point of time PTR1 will point to the second last node. So after deletion of the last node, the second last node will point to null, that is the link part of the node being pointed out by PTR1 will now contain a null pointer. Then we will free the space which was occupied by the deleted last node. Here is our modified linked list having the last node as the second last node of the original linked list. Now let's see the function which deals with deletion at the end. Here we come, del end. This is the function which helps in deleting the last node. PTR1, we know what does it signify. Now we will start traversing the linked list from the first node. So we assign PTR equals to root, and how long we will traverse? Until and unless the link part of the node being pointed out by PTR contains a null pointer. So the loop's condition is PTR of link not equals to null. At that point of time only the body of the loop will be executed, otherwise we will jump out of the loop. Now PTR1 points to PTR and PTR points to the next node, that is the node occurring just after the node being pointed out by PTR1. Okay. Now when we reach the last node, that is when PTR points to the last node, we will come out of the loop, and then the second last node which is being pointed out by PTR1 at this point of time will be pointing to null, that is the link part will contain null pointer, and then we will free the space or the Memorial equation which was occupied by the node being pointed out by PTR, that is the last node. Or after this function there is a display function which has already been explained how this display function works in previous videos. If you want, you can go back and just check it out. In main, just see, we have created a linked list, and then we have displayed the original linked list, and then there are three cases which gives the user the flexibility to choose whether he wants to delete a node at the beginning, at the end, or in any position. Case 1 tells the user or gives the user the freedom to delete a node at the beginning. Case 2 helps him to delete a node at any position by taking the value of the key from the user, and case 3 helps him to delete a node at the end. And then we will ask the user whether he wants to modify the linked list further or not. If he wishes, he will press 1, otherwise he will press 0, and then the final linked list is being displayed by calling the display function. Okay, now we will see what will be our output. See, gcc deletions.c, object name p. Okay, successfully compiled. Creating a new linked list. Enter the new node value, let it be 2. Do you want to continue? Yes. 3, yes. 4, yes, I want to continue. 5, I don't want to continue to create the linked list, so I press 0. So this is our created linked list 2, 3, 4, 5. Now I'll press 1, that is deletion at beginning. So just see, this case performs deletion of the first node. Previously our linked list was over here, you can see 2, 3, 4, 5, but now it is 3, 4, 5. 2 is being deleted, first node is being deleted. Do you want to modify it more? Yes, I want to modify to show you all the remaining 2 cases. So I press 1. Which condition or which case you want? Case 2, that is deletion at any position. So it is asking which value I want to delete. I want to delete 4. So I'll press 4. Just see. So see, it was 3, 4, 5 after deletion of 2. Now after deletion of 4, it has become 3 and 5. Okay, I'll show you the last case, that is case 3. You see, it was 3, 5. Now the last node, which was 5, is deleted and we are only left with 3. Now press 0 and come out, and it is showing that the final modified linked list after we have modified it 3 times, it is now presently containing only one node, that is 3. So here we come to the end of this video. Thank you for watching. If you are please like the video, please share the video, and to keep updated with all the videos which I will be uploading, please don't forget to subscribe. Thank you for watching.